All right, part 2. Number 11, we've got division. Skip, flip, and multiply. I've got to factor everything that can be factored. So normal quadratic trinomial, so let's see, that'd be a -5 and a +3. In the denominator, we would have a x minus 7 times 3. I wonder if this one got mixed around too. Yeah. So this, it had mistakes. So this is actually a 4x on the bottom. So then it would be x plus 3. X minus 7, x plus 3. Now, division is multiplying the reciprocal. So I change it to multiply, and I reciprocate the second fraction. Now I can cancel anything that matches with top and bottom. We've got x minus 5s, we've got x plus 3s. And your answer is anything that didn't get crossed off. Boom. Number 12. And the domain. Okay, so I think you have to find the domain first. But which you have to factor first too. So x minus 4x plus 2. And then on bottom we have x minus 7, x plus 2. And we're multiplying by this guy. So the domain is about what the bottoms can't be. You can't have 0 on the bottom of a fraction. So if x was 7 or -2 or 4, it would make zeros on the bottom. So our domain is x is not allowed to be 7, -2, or +4. And now for our answer, those guys cancel. Those guys cancel. X minus 8 over x minus 7. Subtraction. Adding and subtracting, you need a common denominator, and we have the common denominator, x minus 5. So we do the operation to the numerators. 8 minus 17 is -9. Number 14, we do not have a common denominator. So I need to rewrite our problem in factored form. Anything on the bottom that can factor, we would do that. Okay, now we need our denominators to look the same. They both have an x minus 3, that's great. The first one has an x plus 3, so I'm going to multiply that in top and bottom to the second fraction. Now our denominators look the same. So our common denominator, x plus 3x minus 3. And our numerator now, 5x plus 9 minus 4 times x plus 3. Which we have to multiply out and simplify. So when I distribute, well, I'll write the first part too. 5x plus 9 minus 4x minus 12. 5x minus 4x is x. 9 minus 12 is -3 over x plus 3x minus 3. And then you'll notice the x minus 3's cancel. Final answer, 1 over x plus 3. Perform the indicated operation. We have rational over or divided by another rational expression. So t minus 4 over, I'm going to factor this guy because it can be and we need to factor it so we can cancel some stuff, hopefully. Let's see, t, what would that be? Oh, I'm messing up our day. I think maybe this is another one that yep, this is another one that had mistakes, a mistake. So on your copy, it will say negative 5t for that middle term. Everything else looks good. All right, so that would be minus 8 and 8 times 3 plus 3 to add to negative 5. And it's divided by t minus 7 over t plus 3. So I'm going to multiply and reciprocate. T plus 3, t minus 7. And t plus 3's are canceling. So we have answer of t minus 4 over t minus 8 times t minus 7. Sometimes you might see that bottom, it gets foiled out as your final answer. Your guys' test is going to be multiple choice, so you'll just have to recognize that what's 8 plus 7, 15. Recognize that that's the same thing. That these answers would be the same thing. Number 16, fraction equals a fraction. When it's just a single fraction equals a single fraction, we can cross multiply. So when I multiply x plus 3 times x plus 2, I'm going to FOIL that out. X squared, outside is 2x, inside is 3x for a 5x. 3 times 2 is 6. Equals, and now multiply x minus 4 times x minus 3. X squared minus 3x minus 4x is minus 7x. Negative 4 times negative 3 is positive 12. Now I would want to put everything on one side equal to 0. When I subtract x squared, both sides, our x squared terms disappear. So we have 5x plus 6 equals negative 7x plus 12. I'm going to add 7x to both sides. That gives us a 12x on the left. And then we're going to minus 6, giving 12 minus 6 is 6 on the right. Divide both sides by 12. So x is 6/12, which of course reduces to 1/2. And that was it, just solve. Another solve. But this time we have two fractions. They're being added on the left-hand side. So I can't cross multiply on this one. What we have to do is go through and multiply each fraction, multiplying both sides by the LCD. So what I'm going to do is first I want to factor that guy. So we have 3x over x minus 2 plus 2x over x minus 5. I'm leaving lots of room so I can do my multiplying. 5x squared minus 16x plus 21 over, I'm just looking at my answer key here to see if there's any typos like there have been, but there's not. Okay, x squared minus 7x plus 10, that is going to factor into x minus 5, x minus 2. So on the denominators, we have an x minus 5 and we have an x minus 2. So that is our LCD. That's what we have to multiply each of these by. What we're doing is we're multiplying both sides of the equation by that. But this side has two things, so it's getting distributed. X minus 3, x minus 2, x minus 3, x minus 2, x minus 3, x minus 2, and that allows us to cancel. X minus 2's cancel in this first fraction. What did I wrote 3's instead of 5's. Sorry. I don't know where I am. 5, that's a 5, and that's a 5. X minus 5's cancel there, and they both cancel there. So what we have left over now is 3x times x minus 5 plus 2x times x minus 2 equals 5x squared minus 16x plus 21. Distributing and combining like terms. 3x squared minus 15x plus 2x squared minus 4x equals this guy. And it's quadratic. I want to get everything on one side. I'm just gonna combine these on the left hand side first. 5x squared 15 and 4 minus 19x equal, oh look at that, our x squared terms are gonna cancel again, so it's not even quadratic. I think they're making these too easy. Minus 5x squared both sides, and then I'll add 16x both sides. Now we have negative 3x equals 21. Divide both sides by negative 3, giving us negative 7. And I'm gonna, remember, I should have done this at the very, very beginning. Our denominators were x minus 2 and x minus 5. So the domain, or the restrictions on x, are 5 and positive 2. Remember, if you get one of those, you have to cross it off in either no solution or only one of them. But this one wasn't quadratic because our x squares canceled, so we only had one answer instead of two, and it was not in the list of restrictions, so we're good. All right, radicals, chapter 5. Okay, there's a couple ways you can do this. I like this way. 64 is 4 to the third. I'm going to leave x to the 12th because 12 is divisible by 3, and so is 30. So the third root of 4 to the third is 4. The third root of x to the 12th is x to the 4th, because you would have x to the third, x to the third, x to the third, x to the third. You could factor that out or separate them, and there's 4 of them, so each one is an x, so you'd have x times x times x times x. The shortcut is just to go 12 divided by 3. And then 30 divided by 3 is 10. Boom. No radical left. Remember, sometimes you had stuff that stayed inside, so you would have to deal with that. Number 19. What value of x makes the following equation true? Okay, so like, what does this number have to be here so that this whole thing equals that whole thing? I'm going to simplify, since this is written with fractional exponents, I'm going to write this one as a fractional exponent. The sixth root of y to the 1, would be y to the 1/6. And then on the left-hand side over here, if we're dividing the bases, we can subtract the exponent. So I could simplify that left-hand side, and that would be y to the 3/2 minus x over 3. So you can see it a little bit better now. I got a y on each side, y to some power, and so that means the powers can be set equal to each other. So 3/2 minus x over 3 equals 1 over 6. We've got ourselves a little rational equation again. So the LCD for 2, 3, and 6 is 6. So I'm going to go through and distribute through, multiply each of these by 6. I guess I didn't really need to put it over 1, but whatever. 2 goes into 6 3 times. 3 times 3 is 9. Minus 3 goes into 6 2 times. X times 2 is 2x equals 1. Subtract 9 both sides. 1 minus 9 is negative 8. Divide both sides by negative 2, and we get that x is equal to 4. And yep, that's it. Boom, boom, boom. And number 20, last one for this part 2 video. We are adding and subtracting radicals, so we have to simplify them first, and if they're like terms, we're able to combine them. Okay, square root of 25x to the 7th. 25 is a perfect square, so I'm going to leave it alone. X to the 7 though, 7 is odd, so I'm going to make that x to the 6 times x. I think I'll just simplify it now. The square root of 25 is 5. The square root of x to the 6 is x to the 3rd. 6 divided by 2 is 3, times the square root of x. Plus 4x squared times the square root of x squared times x. It's a square root, so I'm gonna make it x squared, factoring that guy. Simplifying, the square root of x squared is x. So this one would be plus 4x to the 3rd, because we've got the x squared in front. This guy came out, so multiply them together, times the square root of x. Then we have a minus 5x times the square root of, I'm going to make that x to the 4th, times x, and the square root of x to the 4th is x squared. 4 divided by 2 is 2, and that would be minus 5x to the 3rd times the square root of x. So I wrote it kind of wonky, but there we are. And these all have an x to the 3rd on the outside, a square root of x in for the radical, and so they are all like terms. And I'm noticing we've got the 5 minus 5 is 0, so final answer 4x to the 3rd times the square root of x. And that's part 2.